let's look at linear equations, or the equation of a line, right? And when we're looking at linear equations, they can be written in the form of y is equal to mx plus b, right? Now this form of a linear equation is called the slope-intercept form, right? And specifically, this is the slope y-intercept form. B here is the y-intercept. M here is the slope, right? And x and y are just points that exist on the line. We know that any point that exists on a line will satisfy the equation of the line, right? So x and y are actually going to be variable. Now, the y-intercept is basically where the graph will hit the y-axis, right? So we know that when a graph hits the y-axis, x is 0. And the slope is just really the rate of change of the line, right? So if we were looking at the slope is the rate of change of the line, and we can look at this as the rise over the run, okay? Which is basically y2 minus y1 over x2 minus x1. So what that looks like if I was to just create a generalized sketch on where you would find this point, let's say negative 2 and 4 is what you're looking at. Negative 2 and 4 would be found in the second quadrant, because we know that x would be negative and y would be positive. So we can say that A here is here, negative 2 and 4. I'm not drawing this to scale, guys, right? You would probably have to use like a grid system to do that. And B here is 4 and 6, it's positive, so I'm going to say that it's located somewhere here. Okay, maybe this is 4 and 6. This is point B, okay? And maybe this is the line, right? So we can see that this isn't an actual line, it's just a portion of a line, and we call this portion of the line a line segment, right? And these 2 points that make up the line segment, they're called endpoints. Now if we're looking at this, we can call this guy point 2 and we can call this guy point 1. If I'm finding the equation of this line segment, right, I need to solve for the slope as well as the y-intercept. So I'm going to write my template, y is equal to mx plus b. I'm going to first solve for my slope. So my slope here is y2 minus y1. I'm going to call this guy point 2, so this is y2, and this guy here is x2, right? And I'm going to call this guy point 1, so this is y1, and this is x1. Okay, and I'm going to plug it into the equation. So you get y2, which is basically 6, minus y1 here is 4, x2 here is 4, minus x1 here is negative 2. Okay, so if I plug this in, I get 2 over 6, which is basically 1 over 3. Okay, so that's the slope of this line. It's 1 over 3, right? And the next thing we want to do here is we'll plug this back into the equation. So y is equal to 1 over 3x plus b. And the next thing you want to do here is solve for b. B is the y-intercept, right? So to solve for b, we can actually use one of these 2 points, because we know that if any point lies on this line, it'll satisfy the equation of the line. So I can use any of the 2 points. I'm just going to use point A. So A is negative 2 and 4. If I plug this in, you get 4 for y, negative 2 for x, and then you can solve for b, right? So you get 4 is equal to negative 2 over 3 plus b, and in this case, if I solve for b, I'm just going to move this guy to the other side. B here is 4 plus 2 over 3, right? Now remember that you are adding fractions together, so you need to make sure the denominators are the same. I'm going to multiply 3 to this guy. So b here is actually 12 over 3. It's the same notion, plus 2 over 3, and you get 14 over 3. So therefore, the equation of this line is y is equal to 1 over 3x plus 14 over 3.